Hello everyone! Today I wanted to show you this little example that I did, which is to control materials and shaders in Unreal Engine from TouchDesigner. Here I have this base that I created settings for, and they are sorted here. So it fetches the parameters, and then you can control, for example, the metallicness, the roughness, and the color, for example. So I can change the color. And these are going to be stored, of course, within these components. Every time you play, it will follow. For example, the world position offset changes like these weird blobs going. There is emissive strength, which you could actually bring quite high or not. And it's just a setup that instead of sending values in a pack, it's sending them individually using a new update that I did to the tool. And I will just, let's jump into it. I'll show you how it actually works. Let's check how it works in TouchDesigner. It's quite straightforward. We have a base, which I called material settings, and I customize the parameters. You can do that by here, customize a component, and I can add many parameters. It's important to know, for example, that a parameter name is not the same as the parameter label. The label gives you the actual descriptive name, and the parameter name will be the one that is going to be set here as the channel name. And that's important because I'm going to use these ones to set it in the shader of Unreal Engine. And I'm going to match both the parameter from TouchDesigner to the material parameter in Unreal Engine. This basically will allow the manager to automatically control those parameters, and we don't have to do it manually ourselves. And I'll just show you how that works in Unreal. In TouchDesigner, the setup is quite similar. All you have to do is to get the actual chop, to control it and send it as floats. And here I don't want to pack the values. They're going to be sent as single values. And I also toggle the append ID off, and I will show what that is a bit later because it's part of the new update. You can see here the 2.1, but just leave it as it is at the moment. And let's see how this manager actually works. From previous examples, most of the way and all the examples I did is actually we are using the modules as components. If you would like to get the float before, you had to come here and say get the float like this. And once you had it, you had to type the address, right? For example, if I wanted the metallic, I would now say here metallic, and I would get the float, and I would do something with it. Well, when we deal with this type of dynamic inputs and we don't really know how many we will have, or we want to have it a little bit more controlled, right? So we'll have to do it one by one, right? Here we have 4. Before you had to have 4 like this. That's super inconvenient. And thanks to talking with people that got the tool and is working with it, I got to this approach, which is super convenient. And I will just show how it works. All I'm doing is to create a material dynamic instance. This will be the material we are going to set the parameters to, and it's stored as this DMI material, and it's set to this static mesh which I made. It's a weird blob rock that is here, static mesh, and here that's how you can see I grab this static mesh and I set it as the material. That's for the material part. Then how does it actually work in terms of generating these modules? Well, I made a few changes in the code so you can actually spawn them by setting the address as well. And that's this event, right? So here, this event, which is called create get floats. If I double click, you will see what is actually happening. We have an event that triggers a for loop. This for loop is being driven by this array of addresses, and I called it float addresses. And if I check the values, you can see here that I have the address metallic, the roughness, the emissive strength, and the world position offset. These actually match this array of addresses, and that's actually quite it. This for loop is now gonna add a component of get float within this actor, and this is actually the same as if we do it manually, right? So when we do this, we are actually doing the same as this, technically. So I can actually delete this, and I don't need it anymore. I can spawn them like this, and I use the array, which means that I use this value. The element is this value, and I'm going to set it as the address. Well, right now, this array is going to do it 4 times, and it's going to create it, right? Before, if we wanted to use the value, we also, I'll just put it again, let's say get the float, we also had to come as the event binding, right? So this is dispatcher that is bringing us the value. So if I wanted to do something with the value, I had to get the float. As I mentioned, if you had 4, you needed 4 of these, very annoying. We don't need that anymore because actually we can bind to this component, and that's what this is doing. This is binding, it's creating this event, and this is going to be 4 events, right? Because we have an array of 4. And it's passing the values to this new function, which is called setScalarParameters. In UnrealEngine, when you want to basically adjust a material and you have a dynamic material instance, it has this function called setScalarParameterValue, and all it is a float value, right? This will be asked to have a name, a parameter name, and a value. Well, technically, this is already the setup that we have, so we already kind of done. The only thing is to understand maybe how it's actually working within the material itself. So I'm actually gonna open it. It's here in this folder of material control. This is the material, so I will just open it. And you will see that I have material parameters, so these are the scalar parameter. And this is called metallic, this is the roughness, and you can already see that the names are matching, right? It's quite important. I have the emissive strength, I have the WPO for the world position offset. These are for the colors, so this is a vector 4. In Unreal, this is set as a linear color. And the names of these parameters are exactly the names that will come from this address, because I have them matching. And then what this does is gets the material instance and sets the scalar parameter value, which is super convenient. This would not work if my name of, for example, metallic, if I would change it to metallic 2, for example, I'll compile, I will save. And if I play now, you will see that probably the metallic will not work. You can see. But the metallic is connected because the component is expecting actually that value. It's just that our material doesn't have that value, right? So it's important when you do it like this to actually match those values. And now it will be connected again because it's expecting the same specific value. And this is exactly the same way that we do it for the color. And I have another array called color addresses, which have the base, 0, edge, and emissive, is these 3 different ones. And I have here the address that actually represents the color with the 0 at the appended. And it's actually doing the same. Instead of a get float, spawns a get color, we pass the address, we bind an event, and then we set a vector parameter. And the vector parameter in Unreal is just a vector 4. You can see here RGBA, and it's a linear color structure, which is the same that the color get color OSCT gives us. So it's perfect. We can just send that. And that is why I can actually just change the colors like this. I can make it orange or change it whenever I want it. This one looks really cool, actually. So now let's say that I want to add a new material and I want to expand this a little bit. I'll just show you how to do it and why this is so powerful to do it like this. For example, I can just go to the material. Let's say we want to make, let's see, I'm going to just freestyle it a little bit. You can see here this world position offset is only affecting these edges. So maybe we can make a slider that will affect all the thing. And the way this we would do is that, let's see how I actually did this. So that I'm multiplying the vertex color of the mesh by the world position offset. So what I could do is to add the lerp, and actually we can lerp between this mode, right? That it has the edge displacement, and that goes here, and previously from the multiplication, that would probably be all of it. Before doing that, let's see if actually is correct. So I'll just check it. Yeah, so now you see that without that multiplication, it's expanding all of it. So let's say we want to control either of, right? So we have a 0 to 1 value that allows us to control that change. To do that, we have this lerp. This lerp will have an alpha. The first will be the multiplication, and the second will be without, right? And this is going to go to the world position offset. Now I have to make a parameter that controls this. So let's call it, how do we call this? WPO. alpha. And notice that I'm typing the first as an uppercase and the following as a undercase. And this is because the way TouchDesigner is going to create the naming, and because it's a float, I know this will actually be like that. So I will just leave it like this, WPO alpha. And this is going to go into the alpha. Great, now we have a parameter, but we have no control over it. There's no way we can interact with it. Well, it's really simple. We are going to make a new flow, well, a new slider here. So I'm just going to right click the material settings, and I'm going to create a new float. I'm going to call it, as we said, the WPO fate. No, how we call it? I already forgot. Alpha, there we go, alpha. And notice that this is not matching exactly the same name, but I'll show you in a bit. This is a TouchDesigner thing. And you can see now my thing is actually matching the name, right? I'll just put it under the world position offset. And this is the difference between the parameter label and the parameter name. The parameter name in TouchDesigner, when they are custom, they always start with an uppercase and they follow with all undercases. So this, you can see that's why it's formatting it to this name. That's actually kind of it for TouchDesigner. You can see it automatically appears here as a value, and it also automatically will appear here as a candidate to be part of the module system here. So if I play, you will see that the WPO alpha is not connected because our manager is not being asking for it. So it doesn't change anything here. What do I need to do? Very simple. I just need to add it into the float addresses array. And here I have to open a new one, and I will type the WPO alpha. And if this name matches, we can see if it's actually going to work. You can see now that I have a slider that already controls this lerp, right? It's controlling the lerp of the shader. And all we had to do is to add a specific name and make a component in TouchDesigner. And that's actually it. Just super convenient, actually. And I really like this. And something quite important to know of this approach is that if we could set, for example, the set debug of these components, right? You can actually see the values coming in. You will see that if I change this new component, it's only that one that is changing, which was also something that quite a lot of people were asking for, because they wanted to send a collection of values, but individually, only when that value was changing. Well, this is the solution for that. Now, only when the value is changing, you can actually control that. This is super cool because any way in TouchDesigner, you could now automate or modify. Oh, what is that? That's not what I want. You can modify this component, right? So you can actually create a connection with this LFO to this alpha. And I'm gonna, you can already see it's going a bit weird because we send a negative value. It's kind of cool. I kind of like it. If you want to set from a 0 to 1, here you can do a tick from 0.5 to 0.5, and now it's oscillating between 0 and 1. And we made like a controller for it. You can see that it's super responsive. And of course, you can always go like whatever you really want to do, which is quite cool. So this is a way to create this type of setup. It's really convenient. You can just create this. You can even have it in the detail view. So when you select your blueprint, you can have it here set up. And you would just not even need to go inside the blueprint. You can just here add those new values and you can just work with it. That's it for this update. I made this tiny example. You can find it here again. You will see it's inside here. There are just a few more things I want to go and brush off as things that I changed. This unfortunately will break the functionality between the previous version and this one, but hopefully it will stay like this in terms of changes. What changed mostly has been like the structure of the address, and it's becoming a little bit more open. In the future, probably will be easier to connect other programs thanks to this. And I also just want to show you a little bit what changed in TouchDesigner. Just quite minimal, but it actually is worth to check. the first thing that changed, let me stop this for a second. We'll just show you, for example, this get event. If you open the blueprint and you check the component, you will see that you don't no longer have the OP, the operator name parameter. You have this address setup. This is basically going to be a lot easier to check and set an address. I think like I had the operator parameter just because of the process and development of this tool. But as I am developing, I just realized there's just no need for it anymore. This makes things a lot easier. What this means is that when you get the component, you just give it an address, right? The only thing that TouchDesigner can get issues with is the naming of certain values, right? For example, you can see that a noise usually defaults to have this channel name. And if we don't have a way to distinguish these channels, for example, from this flow to another, we can have like disruptions between the messages, right? We could be sending different values to the same address. That is why I created this new value in every single module, which is called append ID. And append ID, all it will do is to get the name of the operator that it's checking, and it's going to append it to the address, right? So here you can see if I append the ID, it will give the name. I made it an option because if you have a small project, you might not want that, right? Maybe you want the simple name. That's why you can toggle it off, and now you just have ramp1. For example, if now I would play, you will see that it's red because it's just not gonna find it, right? But if I go to the event and I say ramp3, for example, you will see that it's now connected. But if I append back, it's not gonna work. So this is just a way to sort of give you the space and also the options to make it more controllable and a little bit easier to set up. So for example, here bit event like RAM4, and it's now going to be connected. Something else that also changed is this part where before, when you didn't had a pack in a multiple channel sender, like could be the vector2 or the vector3, etc., you basically only had the first 3 channels as an option, right? I also found that a little annoying for myself because if I wanted to target a specific one, I had to basically select that specific channel to send. It was a bit weird. So what this is doing is it has the same functionality as the pack. You can see that nothing's going to really change on the channels, but basically it allows you to target which one you want from the pool, right? This null vector, for example, has like 49 channels, so it's going to divide them by 3 and group them in groups of 3, right? So that's why you can see here there's a channel 0, 1, 2, that's the first group, etc., right? It's going to append the index to the address, and that's the only thing that really changed for this one, which means that you have to add that index, and that's how you get that specific value. This is the same as before. You can trigger the ID or not, and makes it much more easier to get the values. That is basically means that if I want the specific position 3, I'll just compile it and it would get that one. And you will see that it now gets here. Really convenient to not have to select chops and things. You can just do it from here now. More things that changed. The senders in TouchDesigner, the receivers in TouchDesigner had quite a bit of a bug, and the bug was due to the buffer of the OSC operator. Now it's fixed. If you get the values, these values will stay, and you can basically have it, right? You will see here this is going to stay, even if you're going to have a lot of messages in this department of the floats. I don't know, so that's also fixed, which is nice. Another thing that I added, but I didn't try if it works, is the multicast. Someone also asked for it. In the designer, the operator, you can now set it as multicast. It's going to set the correct address. And in Unreal, if you open the menu with Ctrl-Shift-O, you will also have the option, right? You can toggle this one and save it and restart. You could also do it from the project settings here. It's also a setting now. So let's see if I find it. OSCToolset, you will see that you have now the toggle as well. I did not try it, but the options are there if you want to see if it works. well, let me know. I don't even know how that actually would work. But the settings are open, which is nice. The last thing is the organization of the plugin. Now it's one folder, it's not two, for examples in the plugin. It's all the same place. It's a bit easier for me to distribute. You have the OSCToolset/td. This is everything will be inside about TouchDesigner. Here, if you only want the component, it's inside the docs folder. The examples is this file, the OSCToolset examples. And for UnrealEngine, you have inside, you have the plugin folder, and this will be the examples project. Inside plugin, you have this version, and you will have all the different versions for Unreal that are supported. And if you want to open the project examples, is under this UE 5.5, under OSCToolset examples, and you can just open it. I hope you enjoy this example and that makes sense, and have a great day. Bye-bye.